Okay, the red graph over here shows you the graph of y equals 4 minus e to the x. And we want to find the volume of the solid of revolution bound where the area being revolved is bounded by that curve and the line x equals 0 and y equals 0. So basically we have to start out by finding this point of intersection right here, which I did right here. That point occurs when y is 0, and if I solve for x, I get the natural log of 4. The most straightforward method to find that volume is to use the shell method, which means we want our typical shell to be parallel to the axis of revolution, which is the line x equals -3, this dotted line here. And that technique to use the shell method says to take 2 pi, definite integral, from, in this case, 0 to the natural log of 4 of the height of the shell, which is this distance right here from the y-axis up to f of x, or 4 minus e to the x, times the average radius, that is the distance from the axis of revolution to the center of the shell. Well, this little distance right here is x, and so the total distance from the axis of revolution to a typical center of the shell is right minus left, x minus a -3 or x plus 3. Now, to evaluate this definite integral, you're going to have to multiply these two binomials together and then find an antiderivative term by term. So, I mean, for example, you're going to get 4x, then you're going to get a plus 12, and then you're going to get a minus x e to the x, and then you're going to get a minus 3 e to the x. This one is going to be the one where it's not straightforward on how to find the antiderivative. You probably have to use integration by parts. Okay, the other way to do this problem is to use the washer method, which means we'd have a typical washer or disk perpendicular to the axis of revolution. And that would be pi times the definite integral from 0 to 3 in this case of outer radius squared minus inner radius squared. Well, the outer radius would be the distance from -3 out to here. We have to solve this for x. That's why it's a little bit harder. X in terms of y. So I'm just going to go to the next board so you can see how I set up that integral. There it is. Here was the shell method, which gave me 6.1338, blah, blah, blah. And here is the washer method. Pi times the definite integral from 0 to 3. This is the outer radius here, which we get by taking the right-hand endpoint. Remember, this curve looked like this. So this distance right here was the natural log, or ln, of 4 minus y. And then the total distance, this was the line x equals -3, would be the natural log of 4 minus y minus a -3. And then the inner radius would be this distance right here. The inner radius squared would be 3 squared, or 9. Okay, and you can see you get the same answer either way. I would suggest that this method is most straightforward given the original constraints of the problem. So there you go. Hope that helped.